Hey everyone, here's another example from section 2.2. The question says, because of their connection with secant lines, tangents, and instantaneous rates, limits of the form limit h as it approaches 0, f of x plus h minus f of x over h occur frequently in calculus. So we've seen this equation. This is basically finding the tangent slope from section 2.1. And they're just saying that these slopes occur frequently in calculus. But then the actual question is, evaluate this limit for the given value of x and function f. So they want us to evaluate the tangent slope or find the limit. So evaluate this limit for the given value of x and function f. So what you're going to do is you're going to take this function, you're basically going to find the tangent slope. So the first thing I do is I take this equation up here on the right, and I start to use it with the square root of x equation. So I'm going to say that the square root of x plus h minus square root of x over h, and I'm going to say that this is the limit as h approaches 0. And remember, I'm trying to take the limit of this while using the x value here because it says x equals 17. Well, if I try to take the limit of this right now, I'm going to put 0 in, and I'm going to have a division of 0, which is undefined, so I can't actually find the limit yet. So this is kind of like one of those problems that we've done earlier in section 2.2 where we need to rewrite this in a way, use some algebra to rewrite this in a way so that we can actually find the limit as h approaches 0. So because I see I have a square root minus another square root, this is like, it's kind of telling me I should probably use the conjugate of that. So I'm going to multiply by its conjugate, which is square root of x plus h, and then the conjugate is just the addition form of that expression. If I do it to the top, I have to do it to the bottom to make sure that I don't actually change this at all. I want to make sure that I'm multiplying by a 1. Right, we have the top and the bottom being the same. That means I'm really multiplying by 1, so I'm not actually changing what this is. When I multiply this through, this is going to give, if I take the square root of x plus h times the square root of x plus h, I'm just going to get x plus h. If I take the square root of x plus h times the square root of x, and then I take the negative square root of x times the square root of x plus h, they're opposites of each other. So those are going to cancel out. So remember, we do this whole foiling thing. We do the outside, then we're going to add that to the inside. Well, they're opposite signs, so they're going to cancel out. So really all I got to do is look at what's the negative square root of x times the negative square root of, or the positive square root of x. That's going to give minus x over, I'm just going to write this as h times this expression x plus h plus square root of x. So, and I did this for a reason. I wanted to write h times this portion because I can see that I have an h on top. I'm probably going to cancel those out. So let's go ahead and say equals x minus x is going to cancel out. So I'm going to cross those out. The h and the h cancel out. So you can see that I canceled the h with this h. The x minus x cancel out. I'm left with a 1 on top. On bottom, I've got square root of x plus h plus square root of x. Now I can actually evaluate this for the limit as h approaches 0. So I'm going to plug that in, and that's going to give me 1 over square root of x plus 0 plus square root of x, which is going to give 1 over square root of x plus square root of x, which I know then gives me 1 over 2 square root of x. And then I want to evaluate this for x equals 17, right? Because I'm trying to find that instantaneous slope there, that tangent slope. So it's 1 over 2 square root of 17. So this is going to be my instantaneous slope for that point.